Hello friends, this is first video on my channel and I thought to start making a series of videos on artificial intelligence. Therefore creating first video onto the vectors where we will talk about the vectors, how these are used in artificial intelligence, what exactly are their properties and how the similarity between the vectors has been identified and how this similarity can be used to create some real life AI use cases. So yes, coming without wasting any time. So coming to the first slide. So let us understand what exactly vector is, right? And why exactly vector is used for. So vector actually is a list of numbers, right? And it is used to represent the features of any entity, whether it is a living entity or a non-living entity. Let us take an example of a human, right? So let's take these three features of a human: height, weight, and age, right? And here you can see there are three humans which looks different because these features of height, weight, and age are different for each one of them. So these has been categorized into three category. One is a child, another one is an old age man, right? And there is a middle-aged woman as well, right? So this is how exactly they are human, but still they are different. So how exactly we will find out a difference between a vector? Probably there should be some properties of a vector, right? So now coming to the properties part. So based on to these two properties, we can identify the magnitude and the similarity between the vector, right? When we say magnitude, the first property, right? Formally, it is the length of a vector, how exactly of length of the vector will be, right? It is actually measures the strength or a scale or a size, right, of a vector. It will tell whether a vector is a large, it is a small vector, right? And whether that large or small vector is pointing into the same direction or not, that is identified by the angle. And what exactly that angle means? It is actually the pattern or a semantic meaning of that entity, right? Whether it is having some similarity or not with other vectors or not. That depends on the angle part. Let us understand it in more details. First, let us see how exactly the vector will be drawn visually in a 2D XY coordinates, right? Let us say we have a 2D vector, right? So this is the angle part which we are talking about, and this is the magnitude part, the length of a vector. This is how exactly a 2D vector will looks like. In case if a vector is a 3D and a vector can goes to multiple dimensions from 3D to 180 dimensions, right? So if a vector is a 3 dimension, right, then how exactly the magnitude and angle will be calculated? How this actually the calculations happen? Unlike 2D vectors, which have a single angle, right, with the x-axis, a 3D vector has a direction cosines. So when we say direction cosines, that means angles with each axis. It will be making angle with each axis, right? Let us say if it is a 3D vector, in that case, x, y, z will be the axis and alpha, beta, and gamma will be the angles that a vector will be making with respect to these axes. Let us understand it with an example, the calculation part, right? Let us say again the human example. Human one have an age of 10, weight of 70, height of 53 inches, right? Then vector will be represented mathematically like this way, right? And then magnitude will be calculated by the square root of 10 plus 70 and 53, which is something around 89.5, right? So this is exactly the magnitude, right, of a vector. And angle is a cosine reverse of each feature divided by the magnitude, right? And therefore, the angle the vector is making to each axis is different, which is 83.6, 38.6, and 53.0. I hope this gives a high level understanding of the two properties, magnitude and angle. And this is how exactly in a 3D form it will be represented, the three humans, right? So this is just to give how exactly in where the dimensions will get increasing, right? How the vectors will be represented. Just to give a high level view, right? Let us now come to the similarity part, right? What exactly the similarity in vectors, significance of similarity is, right? Vector similarity actually is a measure how alike two objects are, right? Whether it is a human, let us say how alike a human is to an animal, right? How alike the two non-living objects is, how alike a laptop is to a personal computer. So this type of a comparison, this type of similarity can be done with the help of the vector, right? So first for that, we have to convert them into a list of numbers, right? Which we call as a vector, right? So it is actually a mathematical distance, right? So majorly two properties we have already talked about, magnitude and angle, and these are used to identify the similarity, right? As we said, magnitude identifies the strength or size of a vector, right? Which means how big, how large the length of that arrow which we seen, right, in the previous picture, right? How large this length is. It will be identified with the help of the magnitude part of the vector, right? And if we say in the machine learning terms, it is kind of a quantity or intensity, right? Let us take an example. If we represent a Netflix user as a vector, the magnitude might represent how many movies they have watched, right? How exactly the similarity check will be done using magnitude? There is a Euclidean distance, right? We will ask, are these two points close together in space? Are these two users to get closer in the space? Let us say one user has just watched 10 movies, another user has watched 1,000 movies, right? So based on to the Euclidean distance, they are not very close to each other, right? They are far apart, right? So here is the way how using the magnitude, the similarity check can be done. And where this Euclidean distance and this based on to the magnitude, the similarity can be identified, where that is useful for the best scenario, right? When the absolute size matters. For example, house prices, right? House prices are always identified based onto the square foot, right? So where we are predicting the house prices, this magnitude part property of a vector is very useful to identify the similarity, right? Second thing is the angle, right? Angle is what it is actually the direction or the intent, right? Angle tells what exactly the orientation of the vector is, right? In which, what exactly is my preference, right? What exactly is the type of uh, spending uh, I am doing, right? What exactly is my interest, right, in some area, right? So it is all about the angle, right? If we say in terms of machine learning terms, it is the quality or the preference, right? And again, if we take the Netflix example, the direction represents what kind of movies a user vector likes, right? Let us say I'm very much interested into the horror. Someone else will be interested into the romance genre or maybe into the comedy genre, right? So this is an example of the similarity check based onto the angle, right? And it is being done using the cosine similarity. We ask, are these two arrows pointing in the same directions? Yes or no, right? Let us say best example, text analysis or recommendations, right? A 5-page document about dogs and a 500-page book about dogs will have a very similar angle, even though their magnitudes are totally different. Now coming to a much better example, let us try to understand it with a shopping cart example, right? Let us have a scenario, cart A, right? That is a small purchase, buying one apple and one orange. Cart B is containing is a bulk purchase, buying 100 apples and 100 oranges. Based onto the magnitude angle, what we can say? The cart one is a small one, the vector is short because the quantity is low. Cart B, the magnitude is massive, the vector is very long because the quantity is high, right? In terms of the angle, it is 45 degrees. The ratio is exactly the same, 1 is to 1. Even for the card B, it is 1 is to 1. Then what exactly is the result we are getting out of these? In terms of the magnitude, these cards are far apart in distance, right? So using the Euclidean distance, we can tell that these customers are very different because one is spent $2 and the other is spent $200. If in terms of angle, if we say what exactly is the result, these arrows point in the exact same direction. The angle, the cosine would tell you these customers are identical because they like the exact same mix of products, right? They like the exact same mix of products, whether it is one apple, one orange, 100 apples and 100 orange, right? Let us go further in terms of the vector. Let us take one more example. Let us think of two vectors. There is a human A and another is a human B. Human A age is 10 and weight is 70, whereas the age of human B is 20 and the weight is 140. Now, in terms of the magnitude, they are totally different. Human B actually is twice the age of human A, and also the weight is twice of a human A. Whereas if we say in terms of the angles, right, they are identical. Why? Because the age to weight ratio is exactly the same, right? And when we are going to create a 2D graph of human A and human B, the arrows of A and B would overlap perfectly. However, the length of human B vector will be larger than the human A. If we calculate the angle of human A that and human B, both of them will be same. That is 81.87 degree. Therefore, if we convert this into a machine learning terms, both the vectors will be pointing in the same directions. They will be having the same patterns, but will be scaled larger. And if we convert them into some real world analogy, if these were two movies instead of human, if these were two movies, human A is a short clip of a comedy, whereas human B is actual a full length movie of a comedy genre. They are the same type of content, means the angle is same, but different amounts of it, right? The magnitude is different. So I hope that clears more about the similarity factor using the magnitude and angle properties of a vector, right? Now moving to the real life machine learning use cases, right? There can be large number of machine learning use cases where vector is being used. Right? Some of them I have listed them down over here and we'll go through them one by one. First one is the recommendation system, majorly used in Netflix, Spotify, and Amazon, right? Similarly, vectors can also be used in natural language processing, whether it is a text search or whether it is a speech or if we are using some chatbots. Vector search is also very useful in facial recognition. Apart from that, vectors are also used for anomaly detections like fraud prevention in banks, majorly around the credit card systems and all that. Vectors are, as I said, a vector are also used for semantic search, and best example is the vector databases. So first real life machine learning use case is recommendation system. Let us take an example of Netflix. In Netflix, what exactly it does is it creates two vectors. One is the user vector and second one is the item vector. User vector contains the details of the users based on to its history, and the item vector contains every movie, every song that the user has watched. Right? What exactly is the concept behind this recommendation system using vectors? Let us say if a person is watching a lot of sci-fi movies, the user vector will move into the sci-fi region of the vector space. And what exactly is the real application of that? If we take a Netflix example, let us say Netflix has to recommend a movie to a person who is watching a sci-fi movie. The system will calculate the distance, often using cosine similarity, between the user vector and thousand of movies that are available in a form of vector in the vector database of Netflix, and then based on that search it will serve a user with the closest one to those sci-fi genre, right? This is how exactly the recommendation system works in Netflix. Similarly, in the Spotify, it will help in building up the playlist of a person based onto the clustering of the songs using the genre, tempo, and the mood. Now moving the another real life use case, that is around the usage of vectors in the natural language processing and chatbots. Actually, the computer don't understand the word, they understand the numbers. So the words are now being converted into the vectors, which is often called as a word embeddings. So the words which are having similar meanings are then located close to each other in a vector space, right? So let us take an example. In a three-dimensional vector space, the vector for a king is mathematically close to the queen and the royal. Where exactly is really used? First one is the Google search. Second is the language translation tools. In Google search, when it is understanding the search for a running shoes, it will give, it will take all the other similar words into consideration as well. Let us say sneakers and sport shoes when we are doing a Google search. Similarly for translations one, when it is mapping an English sentence vector to the closest French sentence vector. So this is how exactly the vector is being used for the translation as well. Another real life use case is facial recognition, that is Face ID. When we actually unlock our phone with our face, the camera actually is not comparing the image pixel by pixel, right? Otherwise, what will happen? It will fail if any light change or any other factor get changed. Instead of that, it is comparing the vectors, right? The vector that is stored there into the phone and the vector that is generated based onto the scanning of our face at the real time. Now, what exactly is the concept? As I said, the AI analyzes our face, extract the specific measurements like the distance between eyes, nose width, jawline shape to create a unique 128 dimensional embedding, which is actually a vector. And where actually it is used? Security systems, right? That is the best example for that. The system compares the vector of the face currently in front of the camera with the stored vector of the owner. And if the mathematical distance is in the range of the threshold, let us say zero point 0.6 to zero point 0.7, the phone will unlock. So this is another real life use case. Let us move to another real life machine learning use case, that is anomaly detection, which we can call as a fraud prevention as well. Banks use vectors to model normal spending behavior. What exactly is that concept? Let us say I am a user and my typical spending habits will be recorded, right? Like my time when I usually spend do spending through credit card, the location where I have done the spending, what exactly is the amount, what exactly is that trend of amount that I spend, and also the merchant category, whether I spend more into the electronics, whether I spend more into the clothes or whatever it is, right? Based on to that, a cluster is formed of a vectors in a specific region of the graph. And how exactly it is being used in credit cards? Let us say if a transaction occurs and that result in a vector which is very far away from the normal cluster that has been built, right? For example, a high value purchase is happening in different country at 3 a.m., right? The algorithm flag it will flag it as an anomaly, right? Because the Euclidean distance is too large. That is also one of the good use cases. Now move to the another use case. That is the last use case that I will talk about. That is about the semantic search, right? Creating a vector database. Traditional search matches keywords, right? Vector search matches intent. Words become vector. Similar words stay close together. And what is the concept? Let us say if you search for how to fix a leaky faucet, right? A keyword search look for those specific words and which will be near to faucet, right? And then a vector search looks for the concept of the plumbing repair, right? It will bring the plumbing repair to the fixing of a leaky faucet. And where exactly this is applicable? Customer support boards, right? We can type a question differently than it appears in the FAQ. For example, my internet is dead versus no connectivity. And because the vector for both the phrases are close, the bot will find the right answer. That is the last example, right? Use case. Now coming to the key takeaways, right? What are the key takeaways from this discussion that we have done till now? So vector actually is used to describe data of an entity, whether it is a living or non-living. And the magnitude and the angle property of vector is being used to find the similarity between the vectors, and based on to that we can create a number of use cases, and that is how the vector is powering the modern AI. So by this I will end the video, and I hope this is useful for you guys. If you like it, please click on the like and subscribe button. Thanks guys.